Hi guys, today we're going to look at the cosine function. So this is the second of three different trigonometric functions that we're going to look at. So the cosine function is written as y equals cosine of theta. And what it does is it pairs the measure of theta. So are we looking at pi over 6, pi over 2, 7 pi over 6, the theta of an angle in standard position with the x coordinate, because cosine is the x coordinate. So if we look at this point right here, we see that it's pi over 2. So we're saying, okay, so when we have theta is pi over 2, what is the x coordinate, or what is the cosine value? Well, the cosine value right here is the x coordinate, and so it would be 0, 1, so it would be pi over 2, 0. So when I go over to pi over 2, I see that the graph is at 0. Now, this graph actually looks very similar to the sine function. The sine function just is shifted a little bit in a different direction. Remember, it looks more like this. Let's see, in our maximum here, minimum here. So it looks more like this. Quick sketch, not perfect. And it's the same shape, it's just shifted because now we're looking at the x coordinates, but it should have that same generic shape of hills and valleys. So find the domain, range, period, and amplitude of the cosine function. Where do the maximum and minimum occur, and where do the zeros occur? So if I look at the domain, because it's similar to the sine function, it actually ends up looking very similar. The domain should be all real numbers, because I can plug in any value for theta. And then the range, like the sine function, has a maximum value of 1 and a minimum value of -1. So that actually answers this question as well. -1 to, we'll call it f of theta because we're plugging in theta to the function, less than or equal to 1. The period, remember the period is how long does it take for one cycle to complete. So if I say my cycle is starting right here, I'm going to follow this down and around, and it looks like it ends right, don't know what that was, and it ends right here. So to get from the start to the end of the cycle, it's 2 pi. And then finally, to find the amplitude, we do 1/2 of the maximum minus the minimum. So that's also going to give us an amplitude of 1, which we hopefully can see looking at this, because we see that there is a height of 1 or a distance of 1 from the midline. In this case, it's at the x-axis to the maximum or to the minimum. So here's our properties of cosine function. See, y equals a cosine b theta. A cannot equal 0, which should make sense because if a is 0, then none of this exists. It's just y equals 0. B has to be greater than 0. In other words, b has to be a positive number. The reason is because b represents the number of cycles, and so you can't say, oh, there are -2 cycles between 0 and 2 pi. That wouldn't make sense. So it does have to, b will always be a positive number, and theta has to be in radians. We're not going to have 270 here. We're going to have something like pi over 2. So same rules apply as yesterday, where the absolute value of a is the amplitude of the function, b is the number of cycles between 0 and 2 pi, and 2 pi over b is the period of the function. So sketch the graph of y equals 1.5 cosine 2 theta on the interval from 0 to 2 pi. So I'm going to start by filling in 0 to 2 pi. And then remember, I really like those midpoints. So I'm going to put a point midway between them, and then a point midway between those. By the end of this should feel very natural, labeling these. So we're going to have the amplitude is going to be the absolute value of 1.5, which is just 1.5. And the period is going to be 2 pi over b, which is 2. Well, the 2's cancel out, and so we just get pi. So this means that our cosine function, which starts at 1, it should make a shape like this between 0 and pi. So what I'm going to do, I'm going to count by 1/2, just so that I have a nice whole number. I'm not trying to graph in the middle. I've got the space for it. And we have 1.5 right here. So my first point is going to go right there. And then I'm going to find, where does my cycle end? Well, my period is pi, so that means between 0 and pi, there's one full cycle. So I'm going to put my ending point here. I've got -1, -2, and so my minimum is now going to go halfway between those. So yesterday, it was that halfway between those, it crossed the x-axis at that point. But now we're saying, okay, here's my start, here's my end. This is the middle, and then we'll cut it in fourths again. So at the midpoint, quote unquote, it is the minimum. And then halfway between the maximum and the minimum is where it's going to cross the x-axis. So it's going to look like this. And when I graph this, remember that this should have curves. It should not be something that looks like this. And if you make it with straight lines, you won't get full credit because that is not a cosine function. So here's one full cycle, but it says to graph it from 0 to 2 pi. So I need to bring it all the way to here. Now, if I'm starting here, the period is pi, so it's going to go from here to here. It's got to go the same distance to finish another cycle. Halfway between those now is going to be my minimum, and halfway between those is going to be the midpoint, or where it crosses the x-axis. And that would be our graph for 0 to 2 pi. Get rid of that. Okay. All right, so sketch the graph of y equals -1/2 cosine pi theta. So I'm going to start with the amplitude. Absolute value of -1/2 is 1/2. And then the period is going to be 2 pi over b, and b in this case is pi. So the pi's are going to cancel out and we get 2. Now we saw a problem like this yesterday where the pi's canceled out, and when pi cancels out and we just have an integer, I just count by whole numbers. And then what I do is I say, okay, 2 pi, I need to go all the way to 2 pi. That would actually be like here because it's 6.28 something. And so we can just graph it 1, 2, 3, 4, 5, 6 rather than putting pi's on there. And we can still graph it from that interval. It's just using integers because we have an integer for our period. So first thing I got to make sure I notice, and I usually do something like this where I'll like highlight the fact that there's a negative there just so that when I'm going back I don't forget. I'm going to count by 1/2 again. And so I have to remember that negative means I start on the opposite side. So my period is 2. So from 0 to 2 is 1 cycle. Now this means that halfway between those is my, and right now I'm at my minimum, so it's the opposite, the maximum. So halfway between them is going to be my maximum. And halfway between those, it's going to cross the x-axis. Now, when they're getting this close together, it's hard to make it look like a curve instead of a straight line. Just do your best. But this pattern is going to continue all the way to 2 pi. So I'm going to draw my points. And then connect them with this curvy line. It's kind of fun, actually. All right. So that would be our cosine function. Sketch the graph. All right, let's find our amplitude. Oops. Absolute value of -2. is 2. Period is 2 pi over 1/2. Well, 2 divided by 1/2 is going to be 4 pi. So I'm going to put 2 pi on here. I'm going to put my halfway mark, and I'm going to put pi over 2 and 3 pi over 2. And I'm going to count by whole numbers, 1, 2, -1, -2. And I see that there was a negative sign here, so I got to remember, got to remember to start on the opposite side. Instead of starting at +2, I'm going to start at -2. But then here's the problem. The period is 4 pi, so that means that this cycle is actually going to end way out here. It's going to end past the 2 pi. So I'm going to have to I could draw this out if I wanted to, but I think a better way is to look at it as, okay, so if it was 4 pi, what would be my midpoint? Well, half of 4 is 2, so my midpoint would actually be right here at 2 pi. So my midpoint is going to be the opposite. I started at the minimum, so it's going to be the maximum. And then halfway between those is pi, so I put a point there. And then I'm going to connect my dots. And so this looks a little weird, but what we're not seeing is that if we were to extend this for one full cycle, we would be seeing this. We'd be seeing this line continue. However, we only want to graph from 0 to 2 pi. And so from 0 to 2 pi, it just so happens that it only makes half of a cycle. And that's okay. So it might look a little funny. You might see a problem like this on your homework, but that's okay. It's supposed to look a little bit odd right now. All right. Amplitude, oh goodness, is absolute value of 1, which is just 1. And the period is going to be 2 pi over 1/5. Now this is actually going to give us 10 pi. Now they want us to sketch from 0 to 2 pi, but I'm going to do a quick little sketch over here just because that's going to be way off my chart. So if I look at this, I've got 10 pi, I've got halfway between that is 5 pi, halfway between that is 5, excuse me. Okay, 5 pi over 2. But even that, stop it, is not 2 pi. 2 pi is actually going to be right here. So if I were to sketch this, it's a positive one, so it would be something like this. So what I see from my little sketch over here is that I'm going to start up, and that's an amplitude of 1. Stop it. It's an amplitude of 1. And so I'm not even going, if I put a 2 pi over here, I'm not even going to cross the x-axis. It doesn't cross the x-axis until 5 pi over 2, which is going to be somewhere over here. So when I graph this, it'll be a little bit better if I give myself a bit more space. So if I start up here, my sketch is going to be really drawn out, and I can stop right there. And that might not look like anything, but again, we're only looking at a very zoomed in part of the graph. Over here, we can kind of see a sketch of the bigger picture of what's happening. But when they ask us to sketch on the interval from 0 to 2 pi, we're looking at a very limited scope. So for some of them, we were able to see a lot of it, like here, or even here. But on some problems, you're not only going to see part of a cycle, and that's okay. Sometimes you won't see the full cycle. Check Google Classroom for your assignment, and as always, let me know if you have questions.